Everybody, and thanks for joining us on Data Shark. Super excited to have Jim Walker with us from Cockroach Labs. This is a conversation actually I've been trying to tee up for almost a year, Jim. It's one of those things where when I learned about Cockroach, I'm starting to reach out to people on LinkedIn. Hey, I want to talk with you guys, and you know how LinkedIn's kind of become a spam engine these days for a lot of people. So I appreciate you joining us.
Yeah, I'm excited to be here. I'm sorry it took a year, dude. I would have, I love
Listen,
doing these things, I
know. I know. It was partially me, and I mean, I'm reaching out to folks, and like I said, a lot of LinkedIn's kind of become a bit of a spam engine for a lot of people. So,
well, I'm happy we're finally connecting. That's great, Jared.
Yeah. So, I wanna ask you to try and build us a Fisher Price version of what it is that Cockroach Labs uh does, so that we can kind of address the audience as sort of the student audience here. And we've got the architect audience and all of that, but I think it would be really helpful to hear from you. What is it that Cockroach DB does differently, and what does the world look like without it?
Yeah, well, it's funny sometimes when people ask me what does Cockroach Labs do, I say we outfit cockroaches with spy equipment and send them, like it kind of sounds like that a little bit. Funny enough,
that's so
we have
true.
this building. We have this building on 25th Street between 7th and 6th there in Manhattan, and people are like, we just got it, and we put the logo and Cockroach Labs, the sign up in front. And I was talking to people. I was like, people are gonna, walking around New York, they're gonna be like, what the hell goes on in there?
That's
And
true.
sure
That's
enough,
so true. Like the
sure enough, yeah,
layperson.
the tweets are coming, dude. Like people are like, what happens in this place?
People will be setting up cameras all night to see the little cockroaches coming out.
Yeah, especially if you have a home near it. Like if you had a home near it, and
it's like ground zero,
Labs. That's funny.
But so yeah, I mean, look, a Cockroach was really born out of necessity, and really a whole lot of advancement in software engineering, I think. And I think, I am just so incredibly proud to be, originally be an engineer. I've been a marketer for a while, but I've been, deep down in, layers of tech that people have a hard time understanding. That's what I love to do. And some of the advances that have been going on over the last 5 years in particular around, like this broad consumption of what it means to be a distributed system and the value of that. And, I was at a company, my last company I was at, it was about 5 years ago. The CEO of that company, a guy named Alex Polvey, the company was called CoreOS. He called this was the advent of like Google infrastructure for everyone else. Giphy is what he called it. And like, we're starting to live in that world a little bit, right? Because I think people are starting to say like, look, I want to move to the cloud and I want to use all these great things. And like, I can lift and shift, or I could start new and I can do these things. But until they get their head around what it means to be a distributed system, they aren't able to fully take advantage of this net new infrastructure. And so, so you asked me, what's the kind of the genesis of Cockroach Labs? Well, if you look at kind of the most important parts of the stack in terms of the software that people use to build applications, well, I mean, there's the application languages, there's the supply chain of how you move things around, but like ultimately, dude, like the most important piece is the database. And the database is one of these things that's been around, especially on the relational side, right? I mean, we've had System R back in 1972, starting this relational database movement. Our lives live in these databases, y'all. Like literally, like since you woke up today, Jared, you have probably hit Oracle DB2 and Microsoft like what, 30, 40 times, unbeknownst to you. And so like relational databases are kind of the backbone of our lives and God, like our applications that we work. And unfortunately, they were built during a different era. They were built during a different world of compute and infrastructure. And so really Cockroach is kind of the advent of let's reimagine and re-architect the database so that it is native to the cloud. So it's truly not lift and shift. It isn't move and improve. Let's just re-architect and rebuild and say, if I had, start at, function main parentheses, like what are we going to do here? And that's really kind of the genesis of Cockroach. So, really being a cloud database is what, and really kind of trying to define that. That's what we're doing here.
Okay. Yeah. And you know, it's funny you talk about the way most people think about these applications and the code that they build for their cloud application. And what's easy about that code is it's the same code, right? And so you can have that be expanded to a gazillion compute nodes, and you know that's not the problem. The problem is that you have to have this database that will support that application, right?
That's
And that's such a different thing than the application, because it changes all the time. It's changing constantly. It needs to be distributed if you're going to have a lot of people. You know, it would be really or it would be easy if everything was just in one place, but we know that doesn't scale. And when you start to scale, all of these problems begin emerging about, you know, how am I going to deal with, you know, multiple calls and, you know, transactions that aren't completely committed yet, and all of this stuff starts happening. So how and it seems to me like, you know, I created a video about this is several years back, but I created a video about NoSQL, and you know, it was exciting. It was like, hey, this thing is going to be able to roll out, but there was always this thing that was like, okay, yes, I can eventually be consistent, but it's eventually, like, so if I have to do something totally live, I got stuck there, right?
Well,
yeah, speak to that a little bit.
Yeah, I mean, it's interesting. So, like, look, you know, I gave up on the document model somewhere around XML, I think. I don't understand it. I don't get it, you guys. Like, I don't understand, like, this flat model. I have to parse it. I have to do all these different things. Like, I guess I was just born in a different era where, you know, the calculus, the math that lies beneath the relational model makes a whole lot of sense to me. Like, I like referential integrity. I can't think without it. You know what I mean? I like secondary indexes and the power that gives you. And, you know, you know, joins and inner joins and outer joins. And like, there's so much power in that. And that's why the relational database is still what we use under our business applications. As much as, you know, like, I think the NoSQL community wants to make that like the foundation, it's an impedance mismatch, right? And it's not just the consistency thing, which is actually really, really important, Jared. Like, I don't think developers actually think through like consistency level. Are you kidding me? I was a hack, man. I didn't isolation levels in a database. Default, you know, like, but it actually gets really important depending on your workloads. And we're talking about relational databases that are running, you know, I'm sorry, but our nuclear codes and our financial transactions, and like that stuff will never get there because the underlying architecture won't allow for this consistency. But I say more importantly, it's the document model versus the relational model. I think the document model is amazing for certain workloads.
Yeah, application wise, like if you had a certain application for that,
that's right,
a website. You know?
That's right. Yeah, like I need to get information out there to a lot of people, like, and there's not a lot of rights and a lot of consistency things. Like, yeah, great. You know, my data is not going to change a whole lot. I kind of know what the model is. It isn't too complex because I'm telling you what, if you have more than say 3, or I don't know, for me, I guess it's 3, you know, 7 documents that you're trying to manage and you're trying to do some sort of schema change across them. And like, where is that level of complexity drop off for you? Whereas in the relational model and how we normalize and we think about cardinality of queries, like this stuff is really important from a performance point of view, but it's elegant. It's based in math, right? And so this relational model thing doesn't ever go away. I'm sorry, as much as like I think certain, you know, vendors I think want to make that go away.
Sure.
As a computer scientist, man, it doesn't go away, man. But can you get those things and bring that into the relation? Can I take that scale, the resilience, and can we bring that to a relational database? That's what we're talking about with Cockroach, right? Like, let's take all that beauty of the relational database and the relational form, everything that we love, right, and combine that with this scale out, this resilience of the NoSQL stuff. We just haven't been able to do it until now, dude. Like, it's just like there's you know, like I said, like our society advances. We learn from our past. We learn from everything, you know, all the lines of code we write. And just over the past couple of years, I mean, there's been some major advances because as software engineers, we've just grown as a society.
Yeah, it seems like it seems like what's happening is, so you have this sort of chasm between consistency and scalability, and you realize between those two, there's almost like this eternal nuance between the two. As you start to pick apart how to solve this problem, there is actually a way to do it. I remember years ago, again, back when I wrote that NoSQL thing, I remember thinking, I wonder if this will ever be solvable, because this seems to be unsolvable, physically unsolvable, right? Because you've got the demands of the two seem to be unconsolable. Like you can't deal with the fact that this has to be so consistent, and yet this has to be so scalable and have so many users and so many inputs. And I kept thinking, man, I don't know how they're going to solve this issue.
Yeah. No, I'm saying, Jared, you're right. And you know why? There's a hard limit called the speed of light. And I'm sorry, y'all.
Exactly.
Like there's a hard, like we have reached the limits of mankind right now. Like that's what I mean. We've advanced so far that we're reaching these limits, and like literally, how do you get past the speed of light? You don't, right? Like, and so, okay, maybe we change how these systems work underneath. There's always going to be some sort of limit. Like until hey man, when we break
Cockroach is working in the realm of entanglement.
You know what I mean? Right. And so
I was going to say,
like we joke internally at Cockroach Labs, I run this competitive session on your first day of work here at Cockroach Labs. I talk about who we are and what we do. And, in the competitive session, I have like a couple groups of competitors but the number one competitor of Cockroach Labs, we internally for us, speed of light. Because that's what we're playing with. No joke, dude. We ain't joking. Like that really is, because you're right. Like if you think about getting consistent transactions at global scale, I have a user in Singapore and a user in New York City accessing the same record at the same time. Who wins?
Right.
And there's trade-offs there too, because do you want to solve for resilience so that data is available to that person all the time? Or do you want low latency access to that? And what it's doing is it's making people think about their data model differently. Like this advent of distributed systems is making say, like, look it, man, when I built an application before, I had to think about the logical model, right? I had to think about normalization and all these things I was talking about, right? Like that's all really cool. In this new world, in this world of kind of cloud, you have to start thinking about the physical nature of your data as well, because it needs to survive, or does it need to be low latency? And kind of trade-offs between the two is what you're looking at. And doing that at the table level is what we do. It's dude, some of the engineering feats here are just truly phenomenal. Like it's pretty awesome. And by the way, inspired by a lot of great work at Google,
Yeah. In fact, as I was reading this morning, I was like, this sounds a lot like some of the recent cryptocurrencies that have been coming out to build consensus. So like a transaction isn't, consensus has been a part of blockchain for a long time, but the more rapid blockchains that have been released, where you have sort of this smaller level consensus that sort of rolls out to larger consensus. Can you speak to that a little bit? Just that concept of the agreement and how it decides what can be written versus read.
Yeah. So we talk a lot about this a lot, a lot, right? Because for the majority of people who are using databases today, they think about scale or how they get data to different people across the planet as a synchronization problem. Let's write it here and then let's move it. Like in this new world of distributed systems, you don't think about synchronization, right? You think about consensus. And consensus is about like for us, well, you can write 3 times or 5 times or 7, some odd number. And as long as you have a quorum within this concept, this distributed consensus algorithm called Raft, which if anybody's interested in learning more about Raft, it's really cool. The secretlivesofdata.com has an amazing
Secret Lives of Data.
The Secret Lives of Data has this really awesome like representation of how Raft works, but it shows it off pretty well. Like, so if I have 2 of 3 replicas of data saying like, this is what it is, I'm good. I have a quorum. So when we
Right.
write, we're actually writing 3 times or 5 times. And we're not saying, hey, write it once and then synchronize. No, it's consensus. So this concept of consensus versus synchronization is a big deal. And that's how we
Mhm.
get scale, right? That's how we get resilience. That's how we get like this global thing. It's good in a single data center too, by the way. Like, and so
Yeah.
there's just so much power behind that, Jared. It's such a I'm really happy you brought it up because it's such a critical concept to understand.
Mhm. It's so is it allowing is the Raft allowing sort of some isolation so that the interaction can occur in the application without the full globe being involved in every little event? Or like, how does the Raft interact ultimately? And if it's too beyond,
No,
explanation, that's fine. But
I
like, I'm curious how the Raft kind of works with the rest of the world.
yeah. So I mean, underlying, Cockroach DB uses this. HashiCorp Vault uses this.
Yep.
etcd, which is the brain behind Kubernetes, uses
Hmm.
Raft. In fact, our implementation of Raft, we contribute upstream to etcd Raft. Like, Raft is just one of these things. It's actually pretty cool. And if
Yeah.
anybody like is listening and building anything that's a distributed system, understanding how Raft works, yeah, we use it in the context of the database. Are you going to
Yep.
use this in the context of your application? Is actually one of these things. It's an
Right.
algorithm, man. It's a supporting algorithm that allows you to do some really interesting things. Now, the way that it works is it gets consensus. It's basically a replica. It basically manages replicas of data. So you could
Hmm.
imagine, okay, Jared, Rich, and Jim are 3 replicas of the same data. And
Hmm.
I'm the Raft leader, and it's like the application speaks to the Raft leader and says, "Hey, man, can you update this customer record with this information?" Great, okay. It's on the Raft leader to say, "Hey, Jared, Rich, update this record." And as soon as one of you say, "I'm good," I can say back to the application, "Everything's good, dude."
Okay.
Because 2 of
Okay.
3, right? And we have quorum.
Yeah.
Because Jared, if you were late or something failed, you would have to
Mhm.
actually catch up and be in sync with Rich and I. You see what I'm saying? So
Yeah.
like,
Yeah.
it's gaining consensus, and in a database that's really, really important, right? And we
Yeah.
use it extensively. But it's just in a normal application. If you think about, like, you have a service that's running, that's doing some sort of function for you, and you have multiple versions of that, and you want to make that redundant, and you're managing some little piece of data, like, it actually is very broadly applicable in many different ways.
Interesting. So is one of the things I remember back when I was talking a lot of NoSQL is it kind of seemed like NoSQL allowed developers to be kind of lazy in the beginning. Like, they didn't have to have all the requirements in the beginning because there was no real, they could sort of define a schema later, but they could just like start building stuff. Um, do you find that most of your customers tend to be organizations that sort of have hey, I've got a defined project with a, specific schema set, or, or somebody has an application that they want to now sort of formalize in a schema that's, super consistent?
Yeah, I mean, it's funny, Rich, Jared. It's not by customer; it's by workload.
Hmm.
It really
Okay.
comes down to what do you want to do. And like,
Yeah.
look, we get a lot of people who are like, look, we've been using Cassandra for a while. And by the way, you guys, Cassandra is amazing technology. I would
Yeah.
never
Yeah.
say
It is.
anything bad about that, because I do believe that this pandemic would have been horrible if we didn't have Cassandra. Like, all that
Yeah.
streaming,
Yeah.
all those streaming services, the Netflixes of the world, HBO, all of them,
Yep.
like,
Yep.
they use so much Cassandra to do what we. And like, can you imagine us without streaming for the past 2 years, you guys? Oh my
I know.
god.
We would have had to
We
talk
got
to each other.
Yeah.
what
Yeah.
night?
We
Like,
we'd
what
had
would
to
we
talk to
talk
each
about?
other.
I mean, talk Tiger King, Rich.
We would have made it through
Tiger
the first
King.
3 hours of the
Yeah, that's
pandemic,
right.
and then
What would we have talked about without Tiger King?
Exactly. But like, those platforms use Cassandra in a way, like, to distribute this data and get this broad reach and all, and it's
Yeah.
amazing, right? But like, the problem with Cassandra is, well, the power of Cassandra is, if you know what you want to do, you can do some really cool things with it.
Yeah.
The
Yeah.
problem with Cassandra, it's kind of difficult with transactions. The problem with Cassandra is it's difficult to change. You gotta know what you want to do before you
Yep.
actually use it. If I think about the NoSQL databases, yeah, you guys can kind of be lazy and figure out schema later, but what are you building, dude? Like, do you have
Right.
an opinion on what you're doing? And so, I think it comes down to the workload, and the workloads that we see coming to us. Yeah, there's certain Cassandra workloads that are coming to us, but it's like, any type of thing, it's like a system of record. It's like it's payment processing, it's transaction problem, it's inventory management. Here's a good one. Like, oh my gosh, like we see this all the time. I'm a software vendor and I want to actually deliver my software as a service, right? And I have, an instance for you, Jared. I have an instance for Rich. I have an instance for, 5 other people. Well, each one of those has its own database instance probably, right? But like, wait a second, I need a database that's getting the metadata out of all those instances too, right? Like I need something that's gonna, because I'm going to deploy, Jared, yours is in Boston, Rich's, yours is in New York. And so what's the database behind all that? Like, how do you actually manage a SaaS or a service application? Like, oh my God, we get a lot of that. And so it really comes down to kind of like, when you're trying to, any sort of data intensive or data critical application, you're going to go relational. Right. Like it's kind of asking like, why would you use Postgres over NoSQL? Well, that is the question though.
Yeah.
Right.
And and I mean, it makes total sense. And it was actually a bank that introduced me to Cockroach the first time. I was like, what? Like, what's this Cockroach? What? And I thought it was strange that somebody would call their database after a cockroach, right? But I was really surprised, and as soon as I started looking at the information about it, I was like, wow, this is actually really, really cool. That's when I started reaching out to you guys. Like, I want you guys to come on this.
Yeah. So. Well, do you know the where the name came from?
No, but that's actually what I wanted to get into. Like, give us some origin information.
Yeah, I'm happy. I don't want to like. Hey man, I know.
No, that's exactly where I was.
Probably got like a showrunner, and I'm like all over. I told you it was going to be good.
I told Jared. I said before we get off here, I got to understand where the name came from. So
yeah.
So our founders are Peter Mattis, Spencer Kimball, and Ben Darnell. All 3 of them were like in the employee 300 range at Google. So like, and like Peter and Spencer built Colossus or helped, architect and build, which is the backend file system for Google, like where all of our stuff lives, like it's insane. Ben helped build out and architect, Google Reader. Like they were involved in some pretty heavy projects in early days.
Yeah.
But interesting enough, before Spencer and Peter landed at Google, they were in grad school together at Berkeley. And they were roommates. They actually lived in the same dorm room. And those are the 2 dudes who created GIMP. If you know what GIMP is, it's the open source, graphical and
I've used GIMP before. I've used it.
Yeah, it's one of the most oldest, beautiful open source pieces of software ever created. Peter,
they created GIMP.
Yeah, Peter and Spencer built it.
That's great. I used to use
but they had to name it, y'all, right? And so, think about movies in 1992, and it was Tarantino and not Pulp Fiction, right? And the GIMP. Remember that? I'm not kidding, man. Dark humor. So
it's funny.
That's the first product they named. Second product they named it Cockroach, and that was really once when they left Google. When you work at Google, you have these kind of internal tools that you use. Look at like you guys look at the NoSQL movement started at Google. That's big table.
That's what I was gonna say. Like all these things mostly started at Google or Facebook. Like Hive was Facebook, I think, and it's interesting because Google's realm was sort of in this, the totally unstructured data, right? But interestingly enough, like, you guys are in the SQL realm, doing relational. So how did they come to this?
They aren't just. You see, it's a fallacy because it's not just unstructured data. Think about the amount of transactions that have to happen for anything to happen in any system. Think about AdWords.
Totally.
What did they need? They needed basically a relational database that would scale across the whole planet. So what did they do?
They
built something called Spanner. And you talk about like things like Hive or HBase, and I was at Hortonworks, so I know that whole Hadoop craziness.
Yeah.
You know where MapReduce came from? Also,
that's Google,
right? Like,
right.
Yeah. And so there's 2 guys there. I like to talk about them as much as I possibly can. By the way, I'm a child of history a little bit, and I think we should all kind of have a celebration of two engineers that have changed all of our lives. It's a guy by the name of Jeff Dean and another one called Sanjay Gemawat. And if you ever want to read some interesting papers on computing and get a PhD in distributed systems, even TensorFlow, they're behind TensorFlow. Like all these projects I just talked about, those two names are on them. And you know, they really thought, you know, talk about Apple, think differently. I mean, they really did. And so when you're there and you have these tools and you have this, they have Spanner, which is like this relational database that is global and like is guaranteeing consistency. They had Bigtable. They had all these great tools. And so when Peter and Spencer left, just to come back to the story, you know, they built a photo sharing website, and then they were at, I always forget, I don't know if it was Stripe or Square. They were both there kind of early. I mean, I think they sold their thing, and they were frustrated. They didn't have like this kind of version of Spanner. So Spencer and Peter just started writing it one night, and Spencer had to name the Git repo. And living here in New York City, I guess he was inspired. A database he couldn't kill, and he named it Cockroach.
So when they started this, there was just their own, you know, I'm sure that by that point they could just fund their own stuff. Did they just decide to go ahead and start their own code, burning the midnight oil?
Yeah, those two.
Wow.
That, you know, look at Spencer Kimball is really kind of a truly amazing CEO. Honestly, you guys, like I've worked for a lot of, you know, I've been in some great companies, and I've worked for some really wonderful CEOs, you know, and I worked for some technical people who are CEOs, you know, coders, and Spencer to this day is still one of the best developers I've ever met. He's pretty phenomenal. He's a great CEO too, which is really kind of, you know, kudos to him. And it's a
sweet spot.
It's difficult to find, Jared. It is really, really difficult. But those two dudes tinker, man. Like I said, they've been coding together for a long time, and they're best friends and stuff. And they were building. And
now, how did it go from that?
Go on.
Well, that's
Jared,
that's actually what I was gonna ask. Like, how did it go from that? Like, you know, just sort of this, you know, working at your house, building this thing to, all right, we have something that's ready for the market. Well, Cockroach came out of nowhere. All of a sudden I was hearing about Cockroach all over the place.
Well, that's marketing, but I'm sorry. No, it's good developer cred is what that is, dude. It's pretty powerful. It's pretty cool tool.
Yeah, totally.
But you know, like, look, as any company, you know, they have friends that they worked with at the last company. You know, they're building something. People are really, you know, great developers. They're interested in solving the same problems. And honestly, like you said, Jared, earlier, this is one of the most difficult software engineering problems there is on the planet. It really is. And I think if you're a developer who's an amazing, you know, software engineer, not a developer, I should say, you know what I mean? Like you want to work on the problem. So, you know, they gathered a collection of about, you know, 5 to 10 people. This is like 2015, 2016 timeframe. In fact, one of the very first people they hired was our VP of people. So we actually had somebody, Lindsay Granawald, who's amazing. And Lindsay, she's wow. She think about somebody who's just like, I can't believe it, 10 people to this, and it's great.
Yeah.
But culture and all those things were very important to the team at the very, very beginning. And it allowed us to kind of maintain this engineering culture, yet still kind of be a company and be respectful about being a company at the same time. Because you guys, I've been involved with some companies where great tech, they didn't understand what it meant to be a company. Right. And that's a recipe for failure, honestly. Right. Like, and so having to be kind of like forward thinking enough, you know, Spencer very early days was thinking, yeah, man, this could be something interesting. Did we think it'd become the momentum we have today? I think, you know, when I joined for sure, but you know, it's interesting.
Well, I was gonna ask you, do you see, and it might be too early on, or maybe it already is happening, but do you see people migrating older applications into what you guys are doing? In other words, like if I've got or is it mostly new applications? So what I'm saying is, like, if I have an old, well, I'm going to choose the most complex one I can think of, which is SAP. Although SAP only works with HANA. Whatever. You see people doing application migrations.
Whatever. Yeah.
Do you see that happening a lot?
So we see a lot of both. I mean, the way it works typically is people start using Cockroach DB with a net new workload. It's just
right. That's what I figured.
There's a risk equation for everybody. You know what I mean?
Yeah.
When it talks about migration of an application, that's really what it comes down to. And to me, what I see time and time again is people will start with a new application. They'll start building on it, because one of the other things about using kind of distributed systems and a distributed database, it takes a different, it's a bit of a different paradigm shift, right? It's like there's this distributed mindset that you build up. Like, how do I build the operational expertise around this? How do I have like the optimization of the data in the tables? Like, even your developers start to think differently. I had Sean from it was in a public webinar. So Sean from DoorDash, I interviewed him, and I was talking to him. I was like, what was one of the biggest surprises? And he was like, look, developers had to start thinking differently, because like when you have a distributed database, right? You, instead of having to say like, I want to insert 10,000 records through one endpoint, wouldn't you say like, I want to insert 1,000 across 10 endpoints? You know what I mean? And so like you start thinking differently about the application. It brings power to that app. So you need to build this expertise. And what happens is about 8 months in, people are like, once you see it, you can't unsee it. You simply can't. And so people start looking at like, oh, I should redo that. I should redo that. And once that happens, it really comes down to your risk profile of the application, and then you as an organization, I think, is really what that's really what it comes down to. Can you do it? Yeah. If anybody ever says a migration is easy on your show, just shut them down, dude. Migrations are tough, dude. Like,
they are tough. They are tough.
Yeah.
That's why I was asking. It's not an easy thing to do. Part of in my other life, currently in my other life, I run the go-to-market for a company called BladeBridge that does code conversion. That's why I was wondering, like, because it seems like it's not just the code here. I mean, we're talking about, well, let me ask you this: the queries themselves. Is there differences in syntax that we have to deal with, or is it just purely SQL? Like, for example, if I had a stored procedure, would I need to wrap that in like a Python code or something like that? Like, what are you doing?
This is great question. So very early on, Peter Mattis, one of our founders, actually made the decision to make us wire compatible with Postgres. So we speak Postgres wire compatible, right? And with doing so, we actually implemented the SQL syntax. Now, implementing the SQL syntax is one thing. Doing it distributed and having a distributed SQL execution engineer is a wholly other thing, right? So to the developer, it just appears as SQL. But you asked a really interesting question. What about stored procedures? Well, we get it. We don't do stored procedures right now. We have a design of how to do this, but it's a little bit of an anti-pattern of the future, isn't it? I mean, isn't this isn't this a remnant of our legacy past, where we didn't have distributed systems and microservices, so we just did it on this weird? Because you know what, the database server was amazing because that was the power of the app. You know what I mean? Like, and so, and we have no way of, versioning these things. It's its own separate language. It's this critical business logic. Shouldn't that just be done in code the way it should be? That's an opinion, and everybody has their own.
I agree with that opinion, actually.
Yeah. Well, more importantly, Jared, when you start to think about distributed systems and distributing the execution, remember the SQL execution, like the same way kind of MapReduce does it, if you will, right? If you start thinking about that, right? Do you really want like stored procedures doing that type of work, right? And within a single data center, maybe, I guess, but what about when you start to go in multiple different data centers and you're starting to get charged these egress costs as you start to, transcend these regional lines and cloud provider lines? Like, it gets really crazy. And so stored procedures to me are interesting in a distributed environment, not as much. And so let's do them where they're supposed to be done. Well, we're going to do some things around this because I think there's some power in that computational model that I think in the future we'll see as something that's valid from kind of more of an analytic point of view and that sort of stuff. I think that's where things start to get interesting.
Gotcha. And when you so really it's servicing those application endpoints when we're talking about these distributed systems and making sure that we can service those application endpoints. Okay, so tell me, what were some of the the moments where was there a moment in the history of CockroachDB where like they knew they had something special? And maybe they knew it from the get-go because they have so much experience in the market, but often when I ask founders this, they're like, "Oh yeah, we presented to this client and they were blown away," or something like that. I mean, was there a moment, maybe even for yourself, that you just knew this was something special?
Yeah, it's such a really great question. I can't really speak for the whole company because I really do think they started with something special in mind. I just knowing the founders that I think that's the way they just are. I mean, they're employee 300 at Google. I mean, I guess they just like to code and they're doing cool stuff, right? Like for me, again, this is just one of these things that once I saw it, I couldn't unsee it. And 5 years ago, I was heavy in the Kubernetes community and still am, still very deeply involved. And like I said, I was at CoreOS and we were going to have our first conference, this Tectonic Summit. It was here in New York. We were looking for an application to run on top of a Kubernetes cluster that was natively distributed, that we can show like, oh, a pod comes down and it comes back and the application still works and all that stuff. And Holvey, the CEO, is like, you got to talk to my friend Spencer, who's building this database. It's really cool. And so we had Spencer come in and do this demo and everything. And we had 18 people on stage and each person bought their machine down and the database and I was like, oh my God, are you kidding? That is incredible. Like, that is awesome. Like total nerd now. You know what I mean? That was my first aha. I was like, and so like, literally it took me 2 years. Like I'm not good at companies until they kind of have a product that's good to sell. Like I'm really good at translating for, the rest of us kind of thing. You know what I mean? That's why I love marketing. I can get really deep and then come to this upper level. But I knew at that moment that I was going to work at that company. Like I flat out knew it. I knew it, and I did. And that was 3.5 years ago. And but I got to say, I think one of the moments that I've had internally here at this company is, as we've grown and as we've started to sell and we see organizations come on, we're seeing like these in the top 5 banks in the world using us. And when you see them using us is one thing, because they try to hedge on tech, and I've been selling into them a long time. But when you see them using us for the workloads that we see them using us for, like these old DB2
Mission
IMS
critical
workloads, like stuff that like the bank is run on, like flat out, and they are risk averse. The value that we can provide in that context, that's where we got to get the chills a little bit right now, actually. It's funny. It was kind of one of those moments I was like, oh my God, oh my God, like this actually could happen here. So I think that was probably the second moment.
Let me. There's something I want to validate here. It can be on-prem, right? So if I was a bank, can I have this inside my bank and not have it be out in the cloud?
Yeah. So yes, absolutely. And so look, at Cockroach was designed as a distributed system and as a cloud database. It is a cloud database. And the funny thing is about like the banks in particular, they actually treat their infrastructure as their own private cloud kind of thing. You know what I mean? Like,
and I do know that.
I mean, Cockroach can do that because it's the nature of the way it was designed, right? Like it's every node is a single binary. There's no like 2 different types of nodes. It's like so scale becomes very easy. I could set it up on this laptop and connect to some 2 instances in the cloud. It's going to work like one single logical database, you guys. Like I have this heterogeneous environment. We have a customer right now who's actually running a single logical database across the 3 public cloud providers. Like literally, I could ask any endpoint in 3 public cloud providers. Like, get your head around that, man. Like, wow. Like,
I'm sure they were glad they did that when it went down last. When did Amazon go down last? I think it was. It
was like a month ago. Yeah, no,
yeah,
like 2-3 weeks ago.
Yeah. So,
but like, think about that. Like, okay, so they're called Form 3. They do payment processing for banks to shuttle money between them in the UK. That can't go down, dude. And so, like, the government says, like, you need to be able to, to survive the failure of an entire cloud provider going away. So that's why they use this in that context.
Yeah.
But like, look at. We are definitely a cloud database. This is what the database needs to be in the cloud. I am convinced. And if it's us or somebody else, this architecture has to happen. We also know that the way that developers consume today is a service. And so, for us, launching Cockroach DB Cloud and having a service that is available, a world-class kind of first-rate service for people, choose to run at AWS and GCP, whatever you want. Like, Yeah, that was very important. You know, funny enough, building a database is difficult, like, but building something as a service, oh my God, you guys, like that's a wholly other task.
I
It's a
know, I
wholly other
know.
problem. Oh my
Yeah, a
God,
lot of
it's
my
so complex.
background yeah, a lot of my background goes into Snowflake, and the way Snowflake approached it, and I'm gonna ask you guys how you guys approach this, but Snowflake really approached their sort of, you know, working on these cloud providers as like you log into Snowflake and you may forget that you're using
That's
Azure
right.
or Google. Like you don't even know actually. I mean, is it similar how you guys have done it in terms of, you know, it's sort of a single pane of glass. You kind of go in, um, and it sort of disappears what the provider is, because there's two
Absolutely.
strategies to this, and I'm
Yeah.
curious which one you
No,
guys
it's
chose.
absolutely. But you know, typically the funny thing is people are kind of building in one of those two environments, so they're
Yeah,
still
yeah.
exposed to it, right? It isn't like this is different than Snowflake. Like the analytics thing is kind of different because the UI to that and how you interact with it is a little different
Hmm,
because this is
hmm.
developers using a database.
Yeah.
And I'll tell you where we want to go with this, Jared, is
Mm.
I don't want the developer to ever think about infrastructure. Like
Yeah,
we
yeah,
literally
exactly.
like our end game, our vision here is I want, you know, 7 to 8 endpoints around the entire planet. I want you to code against a database the same way you would do like SSO with Okta or whatever. Like I
Oh, that'd
want
be
to code
awesome.
against an API. I
Yeah,
want a SQL API in the cloud with 8 or 9 endpoints around the planet, and that's it.
that
Like
would
I
be
don't want to
awesome.
deal with scale. I don't want to deal with. I don't want like. Why do we deal with any of that stuff?
Yeah, yeah.
And for
How
us,
far
you
off
know,
do you think that
that's
is?
beautiful. Yeah. What's
How
that?
far off do you think that is? How far away
Not
is
as far
that?
as you think. It's
Yeah.
not as far as you think. I mean, we launched Cockroach DB serverless in October. That's, you know, a free database. It's single region. Like, but the challenge
Mhm.
is to do what I'm talking about right now. Man, think about what this means because, you know, like I said, Rich is in, between us, you know, and he's accessing his data from the East Coast, and then somebody's
Mhm.
accessing from the West Coast, and I have a customer. Like, where does that data live? Because remember, the speed of light's no joke, right? And so, like,
Yeah,
how do
yeah.
I automate where data lives on the planet?
Right.
Companies have done this. Google, you know what I mean?
Yeah.
So like, how do we do this in general for every application that's being
Right.
built? And those are some really, because we solved the consistency problem. We solved the easing of scale. I don't have to shard. I don't have to deal with
Mhm,
those
mhm.
craziness anymore. We solve the resiliency problem because we're doing this consensus and I can fail whatever I want to
Mhm,
fail.
mhm.
The latency question on that on what see, you know, SQL endpoint in the cloud, just
Yeah.
how cool. Some really great software engineering problems to solve, Jared, and this team is
Yeah.
doing some really cool stuff. It's a fun place to be.
You know, I wrote a white paper titled the Commoditization of Networks, and it talks to, um, it talks about GE and Westinghouse and how they were competing with each other in the early on days of the electricity grid and that network. And then I ask in the white paper, when you plug your phone into the outlet, do you think about what
Right.
generator is on the other side? Do you think it's a Siemens generator or a GE generator? And do you even get nervous about that? It's just like, no, you know. So
No.
the idea is that that there will be a commoditization of these large cloud vendors, and that the endpoint services will be services like what you guys have got,
Yeah.
where you don't even really care about which cloud it's plugged into. The question I want to get into there, though, is, um, you know, the cloud vendors have created these toll gates for getting data in and out. So is that just a
Right.
thing that companies have to say, hey, we're just going to have to budget for this? We're just going to have to budget for the fact that data is coming in and out, and that is what it is.
Yeah. We have to be worried about that. Are you kidding me? They're killing us. You know,
Yeah,
like
yeah.
I think this is one of those things that everybody worries about. And you know, for us, there's this other cool, like this speed of light thing, and what we did to solve that. Like
Hmm.
we have this feature called geo partitioning. And what
Okay.
you can do is at the table level, you can configure the table so that records of a certain, like with certain column values, are stored on certain servers. So you can imagine, I want all German customer records to live in Germany. Why? Well, maybe it's a
Nice.
compliance and privacy thing. I don't know, but maybe more importantly, it's a latency thing. Maybe more importantly, I don't want that data to leave because I don't want to get paid. I
Yeah,
don't want
yeah.
to pay. And so, like,
Right.
Hmm.
letting the database and just being able to configure that. And by the way, we start up a new region and like it'll remove all the data to where it needs to be automatically underneath the
That's
covers. You kidding
awesome.
me? Like That's awesome, right? And so there's ways around it. People don't use us for that yet as much, Jared. That's a complex concept. This data privacy is complex, but why not let the database deal with data privacy? By the way, y'all, like, why are we doing this in our applications? It's error prone. You're leaving a developer to do something that they don't have jurisdictional understanding of X, Y. You know what I mean? Like, let the database do those things. Give them the tools to do it. And so for us, that's how we think about that.
So when you're doing global stuff, like when you've got, say, like someone in the EU, for example, sharing data outside of the EU is, and in any country, actually, at this point, everybody's got their walls up and they're not wanting to share any data between them.
Including the People's Republic of California.
all of them. Exactly. So like, these walls that we have to put up between, so it is what you're saying. Like, you can kind of just say, if the origin is here, keep it here. All replication nodes have to stay here. Like, is that boundarying? I don't know if that's a word, but
geopartitioning is what we call it.
Yeah.
Geopartitioning.
Yeah. Okay.
Yeah. So
is it just based on the origin, or is it just logic that's defined?
No. So we have a way of making it. We have a way of doing it so that it's based on the origin. And remember I was talking about the serverless thing and this global, like, that's going to be a part of that. Like, I created my data. I was in this region. Does it live there? I went over here and I accessed it 5 times. Does it move? Like, that's the future. Okay. We can. Right. The thing is, we can do that, right? Like, how you do that is really difficult. The way we do it today is within each table. So let's say I have a customer table and it's got, it's got my name and it's got, my social security. It's got my, my country code, right? And what I do is I'm overloading the primary key for that table and appending that country code to it. And so basically I can now sort by key all of these records. And I say, look at all the records that have this in the key, this country code or whatever it is, I'm really genericizing it. They can only live on servers that are named EU. And so when I deploy servers in the EU, I name that instance, the Cockroach DB instance, I name it EU. And so the database is smart enough to understand, using Raft again and distributed and how we move data around. It's smart enough to say, like, that data lives on those servers. Now, what's cool, I have, 3 nodes here in Jersey, and I've got, 3 in Portugal, and I've got 3 in Germany. I can ask any one of those nodes. They're all endpoints. They can all service reads and writes. They are all a single consistent gateway to the entirety of the database. One logical thing, I could ask any one of them for the data that lives in, say, Portugal, and it's going to be able to get that and return it to me.
Wow, that's cool.
Right. So it lives, but I can now still access it, which is cool.
Right. So another question I have is around when it comes to analytics. I presume, it's a SQL database, so it's going to be able to cough up records. I'm basically used to, or we're used to sort of acquiring from databases like yours to push them into things like Snowflake. But what about like operational reporting or something like that, where it's more of smaller queries? How does it handle the coughing up of data? Is it truly just sort of, small read writes, or can we do a little bit more in terms of acquisition?
Another great question, Jared. And underneath the covers, that ultimately, when so any database actually writes data to disk. Like, everyone, like, literally, that's what we're doing. At that layer, we actually write data using a KV store. So we're actually key value underneath the covers. Like, you never get exposed to it. It's just SQL. But we're actually doing that. And because we are KV, we actually understand each column of every single table.
Oh, cool.
And so we actually implemented something called vectorized execution, which basically allows you to do like summaries on a column. So like, I want to do my end-of-day totals across my point of sale systems. Great. Got it. You know what I mean? Like, and so we've implemented small things within Cockroach that allow you to do more analytical type queries. But you're right. It's the operational analytics is what I think belongs in the operational database. Like, there was a reason why there was an OLAP market and an OLTP market in our lives. They're fundamentally different problems. They're fundamentally different technologies.
Absolutely.
Down to the way it scans. Down to the way it is literally written on the disk.
Right. And so, I'm not a believer in convergence of these two things. I just really am not.
Yeah.
And maybe, I think we're doing things in Cockroach that allow us to kind of get closer and closer to that, so you can play with those sort of things. But I also think I think those companies that are trying to do analytics are saying like, we're going to do transactions. Like, do you know how hard it is to do transactions, guys?
Yeah.
Good
Well,
luck.
there's a white paper I wrote, almost 2 years ago, where I talk about Snowflake is a truck, not a motorcycle, or is a semi, not a motorcycle.
Right.
Because what was happening is, there was, we'd actually come across an organization that tried to do single read writes into Snowflake, as an application. It was a catastrophe. And the reason it was a catastrophe is it's very obvious why it's a catastrophe as soon as you actually write out the process of looking at the records in a column versus a row. I use the example of, US presidents, and I show, dates and US presidents, and, comparing a column versus doing it in a straight row. I mean, it's totally obvious why it would take forever to actually run a transaction in a columnar store. So,
but they're really smart people and amazing engineers, and that product is amazing. You know what I mean?
That's awesome. It's an awesome product.
I will not dismiss anybody from trying or doing some of these things, because there's some really amazing tech that's been built over the past couple of years. That's one of them.
Yeah.
You know what I mean? Like,
Snowflake's
but you know what? I think ultimately, there's I say this all the time. I think there's two pieces of software that, as man, we should just be super proud of. One of them is Oracle, and the other is Photoshop.
Yeah, the data and the thing that displays the data.
Well, oh my God, like it is.
Yeah,
Oracle is incredible, you guys. And I'm telling you, like, look, if I want to go compete feature by feature with Oracle, good luck, man. I think others have tried that. It doesn't work, you guys. Like, it just doesn't. It doesn't. Like, however. Can you, when you think about competition, you think about markets and the way things work, look at the field is changing. So how do we actually bring a different kind of tool to the field to say, hey, look I can actually give you different things and different value.
Yep.
And maybe the cost model starts changing too, by the way. And I'm not just saying we're going to be cheaper. Let's do this thing where, I can, instead of running 15 instances of a database, maybe I can make a single multi-tenant database. And now, change the compute cost that I'm charging to the cloud provider. That's what we're going to do with serverless, right? Like, how do I make this so that, I'm no longer spending? If I could cut my cloud cost by 10, down 90%.
Yeah.
I'm thinking about that. You know what I mean?
Yeah.
And as long as I'm getting consistent data, great.
There was when Gartner first came out with their Snowflake evaluation, and scoring Snowflake on data warehouse vendors.
Yeah.
I ended up creating a meme on LinkedIn that showed this Formula One driver, and it had a Bugatti on the left, and it had a minivan on the right, and it had Gartner talking to the minivan saying, "Look how many cup holders it has." And I'm like, the race car driver does not care about the minivan. Okay. Like, he doesn't care about the cup holders and things. I mean, it's fine if you want to, talk about all these sort of featurettes that some of these other tools have. What's the full core function?
Right.
What does the person want?
That's
and
right.
when you strip all that away, all of a sudden it's like, okay, so in reality, this is far, 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 far better for this specific use case.
Well.
So I'm with Cockroach DB. I mean, we're getting close to the end here, but I want to. What projects, which groups, who should be coming to Cockroach DB and saying, "Hey, we've got this project, we've got this." Who should be coming and saying, "All right, this is where we need to be"? And I mean, I'm sure it's lots of people, but what's some of the the sweet spot here of because as I've been looking through this, I'm coming up with all kinds of projects that I want to be able to use this with. But a little direction. And how do they get started? And
it's a great question, Rich. And it's funny, like, we talk about this a lot internally. It's like, okay, what are you guys good for? I'm like, well, we're a database. Like, I'm sorry, what's a database good for? You know what I mean? Like, and so it's a little bit of that. Okay, I'm being a little jokey, but it's kind of true. Like if you're going to use Postgres, great. Postgres is amazing, but like, why not have the same syntax and code against that and never have to worry about scaling reads or writes and never have to worry about the database ever failing? Okay, I might not need that on day one. Well, will you even like? Yeah, man. Like those things are difficult, and like even in a single data center, even if you're like, oh, God forbid, if you're thinking you might be global anytime, God, don't even mess around. Like, don't even play around. Right?
Just start on it. There's actually I'm going to share this link. There's a really good blog article on this. It's
and it wasn't
live
by the way,
on
it
acid.
wasn't written by Hunter S. Thompson. It's us.
Okay. but it's about the the betting market and there's all these companies now that do live bets. I mean, it's a perfect use case for what we're talking about here because if you think about it, the transactions have to be solid. And you're comparing something very live, like, which is the instance that thing happens and whether you bet before that thing. And I mean, it's got all of the perfect mix for what you guys are talking about.
That's right.
So that's a good link to go to for that.
It's that side of it, but it's also, remember I was talking about this metadata app where I'm just collecting information off of an assembly line. I'm collecting information off of my SaaS application instances. Like it's those areas where you need transactions. This is, you're a bit write heavy. If it's read heavy, go with NoSQL. If it's read heavy and you don't have a consistency, issue, like just go with NoSQL, dude. I totally get it. I totally understand. And I'm not saying we're good for everything. But I think if you want to if people want to get started, they want to start playing with Cockroach DB. We have a fully managed instance of this Cockroach DB dedicated where it's your own cluster and all these things. It's fully that's what you're going to use in a production instance. We also launched Cockroach DB serverless about a couple months ago. I think we have thousands and thousands of clusters on this thing. It's just an instance of Cockroach that's completely certain. Like I had an instance of the database up and running and one of those no code platform things. I used Retool. I had an application of 82 seconds.
No, that's awesome. That's excellent.
Yeah. So it's just one of these things where, and it's free. It's free up to 5 gigabytes of storage, 250 million request units, which is like kind of a transaction, if you will. And so people can get started there is a great place. But, it's lots of different workloads. And we talk about a lot of them with our customers.
Awesome. Well, it's been awesome having you on here, Jim. The time has just flown by. So the best way to find you guys, would it be to go and start a trial on the cloud one?
Yeah, just try serverless. Cool. I would spin up a cluster on serverless, and then if you really want it, we'll get you a 30-day trial on the full dedicated version. Serverless is still beta. We're still kind of we look to GA that in the fall at some point where but we have people running production applications on that thing today, which is like,
that's awesome.
It's pretty great. So that's the best way.
Well, I'm excited to see what comes out of Cockroach over the coming months and years, and I'm sure we'll end up being part of some of that. So
I'm
anxious to get my hands on it here and start playing around. So
very cool stuff.
Well, you guys, I'm honestly, I would love to talk to you guys again. This has been super fun. For me, honestly, you guys, I'm interested in what's going to happen at Cockroach. I love where I work. This is a fun place to be. I'm just interested in what's happening in the data market in general right now. Like we're having this resurgence of the importance of data, and what is the data market 5 years from now? Man, this gets really interesting. Everything's a data company, so this is a fun time to be alive.
Check out more of our videos because we're talking to a lot of these younger companies. Or companies that are nascent. And it's a lot of fun to hear what's coming out. So,
and it's funny too because you say 5 years from now, right? I mean,
5 years of eternity from now.
I was just on a call with Jared the other day, and he said, "Remember in the old days?" And I said, "Jared, that was 4 years ago." The old days. Remember in the old days?
Oh yeah, like I'm an old codger.
I mean, things are changing so fast in this world. It's exciting. It's really exciting.
It's fun stuff.
And this has been wonderful.
Thank you, Jim, for joining us. And we'll put this one in for the history books.
Great. Thank you, guys.
Thanks, everyone. Have an excellent day.